Here we are going to discuss about Laurent series expansion. How an analytic function can be expanded through Laurent series. Laurent series definition is: let C1 C2 be two concentric circles mod z minus z not equal to R1 and mod z minus z not equal to R2 where R2 less than R1. Let f of z be analytic on C1 and C2 and in the annular region R between them. Then for any point z in the region R, we have f of z equal to sigma n equal to 0 to infinity an into z minus z naught whole raised to n plus sigma n equal to 1 to infinity bn divided by z minus z naught whole raised to n, where an is equal to 1 by 2 pi I integral c1 f of z by z minus z naught whole raised to n plus 1 dz and bn is equal to 1 by 2 pi I integral over c2 f of z divided by z minus z naught whole raised to minus n plus 1 dz. So this is the Laurent series expansion of a analytic function. Here this series expansion contains the positive powers of z minus z naught and also the negative powers of z minus z naught. This is the main difference between Taylor series and Laurent series. In the Taylor series expansion, only the positive powers of z minus z naught will be there, but in the Laurent series expansion, both positive powers and negative powers of z minus z naught will be there. That is the main difference between Taylor series and Laurent series. Also, here in Laurent series, we want to give preference to the region also, whether it lies in between these two circles or C1 on C2 or between C1 and C2, that is in the annular region, like that. So here we want to give preference to the region. Next we are going to some problems. Expand f of z equal to z divided by z plus 1 into z plus 2 about z equal to minus 2 as Laurent series in 0 less than mod z plus 2 less than 1. First of all, look at the function. Here function is z divided by z plus 1 into z plus 2. Here the degree of the numerator is 1 and degree of the denominator is 2. So degree of numerator is less than degree of denominator. Here we want to use partial fraction. That is f of z equal to z by z plus 1 into z plus 2 is equal to a divided by z plus 1 plus b divided by z plus 2. On cross multiplication and making the LCM same on both sides, we get a equal to minus 1 and b equal to 2. Then our f of z will be minus 1 divided by z plus 1 plus 2 divided by z plus 2. This is the first step. Next, here we want to expand this function about z equal to minus 2, which means the factors will be of the form z plus 2 and its powers. Okay, so here we want to make the factor z plus 2. So in the first portion, that is minus 1 divided by z plus 1, here we want to make it as a factor z plus 2. For that we can add or and subtract 2 in the first denominator, and in the second denominator it is already z plus 2 is here, so no need to add or subtract 2 in the second part. So keeping the second part as like this, 2 divided by z plus 2, and add or subtract 2 in the first portion's denominator, we get minus 1 divided by z plus 1 plus 2 minus 2 plus 2 divided by z plus 2. Rearranging the terms, we get minus 1 divided by z plus 2 minus 1 plus 2 divided by z plus 2. Here we want to expand the Laurent series in the region 0 less than mod z plus 2 less than 1. We have some basic expansions. Okay, all the expansions are valid for mod z less than 1. So here we can take minus 1 outside, because then only the denominator will be of the form 1 plus z or 1 minus z. So in the first portion, taking minus 1 as a common term, so the fraction will be minus 1 divided by minus 1 into 1 minus z plus 2 divided by z plus 2. Here minus 1 cancelled, and that is equal to 1 minus z plus 2 whole power minus 1 plus 2 divided by z plus 2. Then again the expansion, we get 1 plus z plus 2 plus z plus 2 the whole square plus etc. plus 2 divided by z plus 2. This is the Laurent series expansion of the given function, which contains factors as z plus 2 and its powers. Also contains positive powers of z plus 2 and negative power of z plus 2. Next problem. Expand e raised to 2z divided by z minus 1 the whole cube at z equal to 1 as Laurent series. Here there is no region. So here we want to just expand this function about z equal to 1. About z equal to 1 means the factors will be z minus 1 and its powers. Here already in the denominator z minus 1 is present, so no need to modify the denominator. Then look at the numerator. Here is e raised to 2z. So here we want to make z as z minus 1. For that we want to add or subtract 1 to z. So e raised to 2 into z minus 1 plus 1 divided by z minus 1 the whole cube. Then multiplying 2 inside, e raised to 2 into z minus 1 plus 2, which means e raised to a plus b form. That is e raised to a into e raised to b. So this will be e raised to 2 into z minus 1 into e raised to 2 divided by z minus 1 the whole cube. E raised to 2 is a constant term. Already the denominator is in the factor form z minus 1. So e raised to 2 divided by z minus 1 whole cube into, what is e raised to 2 into z minus 1? We have an expansion of e raised to z, that is 1 plus z by 1 factorial plus z square by 2 factorial plus etc. Instead of z, use 2 into z minus 1. So the answer will be e raised to 2 divided by z minus 1 the whole cube into 1 plus 2 into z minus 1 by 1 factorial plus 2 into z minus 1 whole square divided by 2 factorial plus etc. This is the Laurent series expansion of the given function. Next one, find the Laurent series of 1 divided by z minus 1 into z minus 2 in mod z less than 1, 1 less than mod z less than 2, mod z greater than 2, 0 less than mod z minus 1 less than 1. Here we want to expand this function in these 4 regions. First of all, look at the function. Here in the numerator 1 and denominator there are product of linear factors. So here we want to use partial fraction. So first of all, 1 divided by z minus 1 into z minus 2 equal to a divided by z minus 1 plus b divided by z minus 2. After cross multiplication and further calculation, we get a equal to minus 1 and b equal to 1. Then our function will be 1 by z minus 1 into z minus 2 is equal to minus 1 divided by z minus 1 plus 1 divided by z minus 2. And considering the first case, what is the first case? Mod z less than 1. Mod z less than 1 means inside the modulus there is only z, which means here we want to expand the function about z equal to 0. So mod z less than 1 means we want to expand the function about z equal to 0. We are moving to the first region, that is mod z less than 1. On mod z less than 1, our function minus 1 divided by z minus 1 plus 1 divided by z minus 2 is equal to minus 1 divided by, already the region is mod z less than 1. All the expansions are valid if mod z less than 1. So here we want to modify like this, that is taking minus outside, it will be of the form 1 minus z plus in the second portion 1 divided by taking minus 2 outside, we get 1 minus z by 2. Here minus minus cancel, so this is 1 minus z whole raised to minus 1 minus 1 by 2 into 1 minus z by 2 whole power minus 1. Then expanding we get 1 plus z square plus etc. minus 1 by 2 into 1 plus z by 2 plus z by 2 whole square plus etc. Since the series contains powers of z or z minus 0. So this is the answer for the first region. Second region is an annular region, that is 1 less than mod z less than 2. Okay, 1 by z minus 1 into z minus 2 is equal to minus 1 divided by z minus 1 plus 1 by z minus 2, which is our function. Next, here also inside the modulus only z term, but here we want to consider the annular region 1 less than mod z less than 2. So first of all, separate this region like this one, 1 less than mod z and mod z less than 2. Then from 1 less than mod z, how can we rearrange it to form mod z less than 1, because all the expansions are valid for mod z less than 1. So here we want to make this inequality like a portion less than 1. So 1 by z is less than 1. Taking the other side, that is mod z less than 2, on dividing 2 on both sides, we get z by 2 is less than 1. Okay, so instead of z, 1 by z is less than 1 and z by 2 is less than 1. Next, moving to our function, here minus 1 divided by z minus 1. This expansion will be valid if 1 by z less than 1. So taking z outside, that is minus 1 divided by z into 1 minus 1 by z plus, next portion is 1 by z minus 2. The relation z and 2 is z by 2 is less than 1. So taking 2 outside, here z minus 2. So taking minus 2 outside, we get 1 minus z by 2. That is minus 1 by z into 1 minus 1 by z whole power minus 1 minus 1 by 2 into 1 minus z by 2 whole power minus 1. Then expanding the expression, we get minus 1 by z into 1 plus 1 by z plus 1 by z the whole square plus etc. minus 1 by 2 into 1 plus z by 2 plus z by 2 the whole square plus etc. So this is the Laurent series in the region 1 less than mod z less than 2. Third one, mod z greater than 2, implies we can arrange mod z greater than 2 for making it as in the form mod z less than 1. Okay, here dividing by z, we get 2 by z which is less than 1. If 2 by z is less than 1, then from that we get 1 by z less than 1. When 2 by z less than 1, then any number which is less than 2 satisfy the inequality. So 1 divided by mod z also less than 1. Our function is this one. So here from the first fraction we want to take z outside, and from the second fraction we want to take z outside. So minus 1 divided by z into 1 minus 1 by z plus 1 divided by z, we get 1 minus 2 by z. So answer will be minus 1 by z into 1 minus z whole power minus 1 plus 1 by z into 1 minus 2 by z whole power minus 1, and giving the expansion, answer is like this. Then the last region, 0 less than mod z minus 1 less than 1. Here inside the modulus z minus 1, which means we want to expand the Laurent series about z equal to 1. So our fraction is like this, minus 1 divided by z minus 1 plus 1 by z minus 2. Already in the first fraction denominator is z minus 1. So no need to modify the first fraction. Then second fraction 1 by z minus 2. So here we want to add or subtract 1. So minus 1 by z minus 1 plus 1 by z minus 2 minus 1 plus 1. Then rearranging z minus 1, here we get minus 1 divided by z minus 1 plus 1 by z minus 1 minus 1. Already modulus of z minus 1 is less than 1. So here minus 1 divided by z minus 1, taking minus 1 outside, that is 1 divided by 1 minus z minus 1, that is equal to this expression. So this is the answer for 0 less than mod z minus 1 less than 1. Next problem, expand f of z equal to z square minus 1 divided by z plus 2 into z plus 5 as Laurent series in the region 3 less than mod z less than 4. Here the function degree of the numerator and degree of the denominator are same. So here we want to use actual polynomial division. By actual polynomial division, the function z square minus 1 divided by z plus 2 into z plus 4 is equal to 1 plus, that is here 1 is the quotient, plus minus 7 is z minus 1 which is the remainder, divided by the divisor. Then here we put it as an equation 1. Then in the second fraction, look at the second fraction, minus 7 is z minus 11 divided by z plus 2 z plus 5. Here the degree of the numerator is less than degree of the denominator, so here we want to use the partial fraction. So minus 7 is z, okay, taking minus outside, 7 is z plus 11 divided by z plus 2 into z plus 5 is equal to a divided by z plus 2 plus b divided by z plus 5. After calculation, we get a equal to minus 1 and b equal to minus 8. Substitute these values in the above form. We get 1 minus 7 is z plus 11 by z plus 2 into z plus 5 is equal to, equation 1 will be 1 minus 1 by z plus 2 plus minus 8 divided by z plus 5. Okay, here the region is 3 less than mod z less than 4. Inside the modulus value, it is only z, which means Laurent series about z equal to 0. So here 3 less than mod z less than 4 is splitted as 3 less than mod z and mod z less than 4. Okay, 3 less than mod z. Rearrange the terms for getting expression less than 1. Just dividing by zv by, we get 3 by z less than 1. If 3 by z less than 1, then it also satisfies 2 by z less than 1. Similarly, mod z less than 4 implies z by 4 is less than 1. If z by 4 less than 1, then any value greater than 4 satisfies the same condition, that is z by 5 less than 1. Then consider our function, that is 1 minus 7 is z plus 11 by z plus 2 into z plus y is equal to 1 minus 1 by z plus 2 minus 8 divided by z plus 5 becomes 1 plus 1 divided by, here the expansion valid only for 2 by z less than 1, so taking z outside, so z outside 1 plus 2 by z minus 8 divided over here z and 5, relation between z and 5. From the second portion we get z by 5 less than 1, so taking 5 outside, so 5 into 1 plus z by 5, that is 1 plus 1 by z into 1 plus 2 by z whole power minus 1 minus 8 by 5 into 1 plus z by 5 whole power minus 1. Giving the expansions, we get this answer. So this is a Laurent series expansion of the given function on 3 less than mod z less than 4.